All right, these notes are going to be on how to graph exponential functions. So with the parent graph, we say we have y equals some number to the x. So it could be 2 to the x, it could be 1/2 to the x, it could be 1/4 to the x, it could be 7 to the x, any sort of different number. And this b value here has several different ways people refer to it. So one is you could say that's the base, right? Because you have a number to an exponent, that's the base of the exponent. Some people call it a growth factor. Growth rate, I've heard. Rate of change. So those are all different ways to refer to whatever the base is going to be for an exponential function, so you'll want to watch out for those. Those words are not considered to be one of the transformations of the graph, but they are important because they do give you specific information regarding the graph. So when we make a chart on this, I'm not going to have you plug in -2, -1, 0, 1, and 2 for all of these because we can actually graph them with less information. And so the information you're going to use to make your chart is you're always going to plug in 0 and you're always going to plug in 1. And I'm going to tell you because those points are going to be very similar for every single graph, no matter what the base is. So if we think about this, if we were to make an x and a y table, and our function is y equals b to the x. If I plug 0 in for x, then I would have b to the 0, and anything to the 0 power is always going to be 1. So the first point we're going to have is 0, 1. The second point we're going to plug in for x is 1, and b to the 1 would be b. So this part, this y coordinate of the second point is always going to be dependent on what parent graph we start with. So if it was 1/4 to the x, then the b value would be 1/4. If it's 2 to the x, then the b value would be 2. The third piece of important information we have is that we have a horizontal asymptote at 0. And the reason that we are going to say that the output of this function, that y cannot equal 0, is because no matter what you plug into an exponent, you're never going to get 0 as the answer. And you can see that if you look at our little bases and exponents table that we made. If you have negative exponents, you see that you just get a fraction. If you have an exponent of 0, you just get 1. And then anytime you have positive exponents, you definitely have just like a number that's getting bigger. And so there's nothing you can plug in as an exponent that would zero out the function. And so that means that your asymptote's not going to be 0. In fact, that asymptote is going to keep the graph from having any negative y values, right? Because if we look at this chart, we only have positive values that happen as a result of plugging in an exponent. And so that means that that asymptote kind of cuts off the rest of the graph. So if I graph this, then we have a horizontal asymptote. We have the point 0, 1, and then 1 and whatever the base is. I'll go ahead and give this one a base of 3. And so we know that the graph would keep growing rather quickly because it's growing exponentially. And when you raise a number to an exponent, it gets big very fast. And then over here, we know that with asymptotes that curves just get closer and closer to them. That's what happens when you have an asymptote. So on the left side, the curve is going to follow that asymptote. All right, so when we look for this, we're going to find transformations just like normal. We're going to go ahead and find all the other characteristics too. So these graphs are written as a times b to the x minus h plus k. The exponent will not be in parentheses, like very, very few times will they actually type the parentheses there, so it won't be printed on your worksheet, but you will know that that's the inside of the function. So as far as finding our transformations, we're going to do the opposite of that. Sometimes you'll see the number in the front that would be the stretch or the reflection or the compression. Sometimes you'll see that with a dot in the front. Sometimes you'll see it written like this so that they can show you what the growth rate is that way. Either way, we're going to look for the base of the exponent, and then we're going to look to see if there's something in front, to see if there's something that would be stretching the graph or compressing. All right, so if we look at this first example, I can see that the base of the graph is going to be 3. That's this right here. There's our base. And so that means that our a value is negative. And so that negative means we have a reflection over the x-axis. This is the inside of the graph, so that means left 2, and then down 1. All right, so if I think about my chart, I'm going to have the point 0, 1, and then 1, 3, because the base is 3. And I have a horizontal asymptote of 0. And I can go ahead and do those transformations. So reflect over the x-axis. I'm going to make my y-coordinates negative. And then I'll go ahead and shift everything left 2. The horizontal asymptote didn't move when I did that. And then down 1. And so what you'll notice here is that your horizontal asymptote, just like when we were doing the rational graphs, your horizontal asymptote actually is written in the equation, and it's the number on the end. All right, so I'm going to go ahead and draw that horizontal asymptote at -1. And then I have the point -2, -2, and -1, -4. And so this graph is only going to have negative values because it's been reflected over the x-axis. So I know this part is going to be growing very quickly, growing in a negative direction very quickly, and then the other part is going to be following that asymptote. Okay, so if we start to look for all the things that we typically find when we look for the characteristics of graphs, we want to find the domain and the range, we want to find the increasing and decreasing intervals, we want to look for x-intercepts and y-intercepts, and then we want to find end behavior. And we want to know if the graph is continuous or has a max or a min. So let me keep writing all these. Continuous, max, min. So many things. Okay, so the domain represents all the x values that you can plug in, how far the graph goes left to right. There's no limitation to a number you can plug into an exponent, and we can see that in the graph because it goes left forever, it goes right forever. So for the domain, we're going to say -infinity to +infinity. The range here is definitely limited. It does go down forever, but it doesn't go up forever. So I'm going to say the range is from -infinity up to that horizontal asymptote of -1. This would be a parenthesis because we don't cross that horizontal asymptote, it just comes up to it. When I look at the increasing and decreasing intervals, I can place my little stick figure right here. This is an x value of -infinity. He is walking downhill, and this is a right arrow, so that's an x value of +infinity. And so he's decreasing from -infinity to +infinity, and he's not increasing at all. So the answer for that is none. X-intercept, it looks like there isn't one. It's not because the asymptote is there. It's not going to cross the x-axis. For the y-intercept, I need to be able to plug in 0. And since I don't really need to, I mean, I could graph it just to make sure I know that I did it correctly. But you don't even really have to do the graph of this to find the y-intercept. But we'll go ahead and do it anyway. So I graphed it correctly, and it looks like my y-intercept is -10. 0, -10, okay. And the behavior is going to take it. All right, so continuity, can you trace it with your finger without picking your finger up? Yes. Is there a max or a min? Is there a mountaintop or a valley? No. I'll put none. All right, so end behavior, we're going to say as we look to the left, as we look to the right. So as I look to the left, I can see that that arrow, it does not go up forever. It gets closer and closer to that horizontal asymptote. And so the y value is getting closer and closer to -1. It's not going to hit -1, but it's going to get pretty close to it. And then as the arrow goes right forever, it is also going down. So I'm going to say y goes to -infinity. Okay, so let's look at this one. Instead of calling it a base this time, I'm going to go ahead and call it a growth rate. just so that we can see that there's multiple words we would use to describe that. So for this one, it's 4. Then I have a 2 in front, so I can say that's a vertical stretch of 2. It has moved to the right 2 and up 4. Okay, so I have the point 0, 1, 1, 4, y equals 0. I need to take my y coordinates and multiply them by 2. So I've got 0, 2, and 1, 8. Shifted right 2, and shifted up 4. And we know that the horizontal asymptote is going to be the same as the number on the end. So y equals 4 is the horizontal asymptote. Okay, so we have the point 2, 6, and then 3, 12, 9, 10, 11, 12. Sorry, that one was pretty far off the graph. My bad. When we do exponential graphs in Math 3, ours will always go up to the right, kind of. It is possible for these to be reflected this way, but reflecting over the y-axis is a transformation that you study in pre-calculus, not Math 3. And so we are always going to see that they're going to follow the asymptote to the left as we learn them this year. All right, so the domain is negative infinity to infinity again. The range, if we go from down to up, the lowest that it goes is 4. And it goes up forever. Then parentheses around the 4 because it doesn't ever hit 4, it just gets close to it. Increasing and decreasing. I draw my stick figure. Ooh. Sorry guys, I didn't move enough and the lights turned off. We have our stick figure, and he's definitely walking uphill. And so this was an x value of negative infinity. Here's our x value of positive infinity. So he's increasing from negative infinity to positive infinity and never decreasing. I need better examples. Again, we don't have an x-intercept because the asymptote is keeping the graph from getting to cross the x-axis. Y-intercept, we're going to have to plug in 0. So in your calculator, you can type it like that, or you can type it like this. It doesn't matter. .125. Okay. Is the graph continuous? Yes. These are always going to be continuous. Is there a max or a min? Nope. And then for end behavior, as x goes left, the y value is going to positive 4. As x goes right, the arrow is going up, so y goes to positive infinity.